Alright guys, welcome back to another wonderful day in the neighborhood. Today's lesson is going to be on graphing motion. Alright, so let's talk about why do we make graphs. So graphs are a visual representation of the data that was collected. A graph makes a simple to read picture, so rather than looking at a bunch of numbers, we have some lines here that are a lot easier to get information from, and sometimes they can even be more detailed and allow us to get extra information that would not be in the data. Alright, so what kind of graph will we use to show motion? Okay, we're going to use a line graph. It shows how distance change as time goes by. Okay, this graph shows a picture of the speed or velocity of an object between the 2 points. The speed is going to be the slope of that line, how steep it is. Alright, so graphing motion reminders. So we're going to take a look at this sheet here. This is going to be the first sheet you guys are going to be working on. We're going to be graphing motion. So you're going to create a graph using these data. We're going to talk about some of the things that you're going to need on that graph, what that's going to look like. So first off, you're going to need the data from a data table that is provided for you. The title, okay, this is what you're calling the graph. The x-axis label, okay, that goes across the bottom, that's going to be our time, and then our y-axis label, which most of the time is going to be our distance. And then 5, a key to show what is represented. Okay, so distance time graph. So time is the independent variable, is plotted on the x-axis. It's always going to be on the bottom. You're never going to see it on the y. Okay, distance is plotted on the y-axis. Sometimes we might have speed here, depending on what type of graph we're doing, but most of the graphs you're going to be doing are going to have distance. And since we're in science class, we're going to use the metric system, so we're going to be measuring that in meters and seconds. Alright, so the data table and axis titles. Okay, so the left column, MIXDRY, if you guys remember that from some of your other science class, put the name of the independent variable, that's what's changed in the experiment in the units, okay, and that's going to go on the x-axis. Okay, so that's the independent variable on the x-axis. Okay, the dependent variable is what is being measured, and that is going to go on the y-axis. That's the one that goes up and down. So your dependent is going to be your distance, and your independent is going to be your time. Alright, so this is sometimes the tricky part a lot of people get confused with. It's data range and interval increments. So you're going to look at the data table and determine the highest value for the independent and dependent variable to figure out the range of the data for each axis. Intervals or increments should be the numbers that are easy to count by. So count by 1s, 2s, 5s, 10s, yada yada. Okay. Each graph block must represent the same value amount. Now I want to talk about this, the same value amount. So let's say I have a bunch of data. One is at a distance of 5 meters, another one's at a distance of 7 meters, another one's at a distance of 9 meters, and then we have a distance of 10 meters. You can't just have those 4 values. On your boxes, you can either go 2, 4, 6, 8, 10, or you can go 5, 10, or you can go 1, 2, 3, 4, but each of your boxes need to be the same amounts. Never design your graph interval increments using only the numbers in your data table. You need to design it based on equal increments from your range. If they don't have a regular pattern, don't use them to label your axis. Once again, just you need to make sure that they're the same size, each of your boxes. Okay. Alright, so once you have finished that sheet, your teacher, your substitute should have an answer key. You'll go over that. Let's talk about analyzing a line graph. So let's say we have a line graph. What information can we get from it? So the slope of the line on the graph, okay, is going to be your speed. Okay, so if we have a really steep line, okay, so that means it's traveling a large distance in a very short period of time, so that means that we have a high speed. If it takes a long time to go a short distance, well, that's going to be a low speed. So the steeper it is, the faster. This is going to be flatter. So if it's completely flat, our speed is going to be 0, right? Our slope of this line is 0, distance over time. So the distance isn't changing. So let's say I'm at 5 meters here, and then in the middle I'm at 5 meters, and then at the end I'm at 5 meters. Well, I'm still staying at 5 meters. I'm at rest. I have not moved at all. Okay? Alright, so what do you notice about the slope of the line segments A through B, BC, CD, and DE? Alright, so AB, how would we describe this? 5, 4, 3, 2, 1. That is slow, correct. That would be a slow speed, okay? Alright, what about from B to C? What's our speed going to be there? Good job, everyone. It's got no speed, speed 0. And then from C to D, our speed would be fast, or at least faster from A to B. And then finally from D to E, our speed would be nothing. Very good. All right, so that would be how we would interpret this line graph. Okay, so graphs tell a story. This graph could show you walked to the store, stopped to talk to a friend, ran the rest of the way to the store, and then ended up at the store. So some of these, obviously, we're interpreting and adding some data to the graph that we don't know, but you can use this to kind of come up with a story, or if you have a story, we can create a graph from that, assuming that we can make up some numbers or find some numbers to go along with it. And so this graph gives us a lot more information than just 1, 2, 3, 4, like 5 different points on a data table would. Alright, so how do you graph a segment that shows the object is returning to its starting position? So what would that look like on my graph, right? So I walked to the store, and what would it look like if I went home? Well, my distance would be decreasing, and so that means it would go back down. Okay, so this would be going back home. So anytime you see this line sloping down, that just means you're returning to your starting position. So I was at some distance far away from it, and then my distance was 0. Well, that means that I'm right next to it. So I went back to where I started. All right, see how the line goes up and down, ends back on the x-axis. This means that we have returned home. All right, so now we're going to try graphing some simple distance time scenarios. And if we click on that link, we should see our second worksheet. So for each of these scenarios, you are going to draw what it's going to look like for each of these. So if someone's walking, what would the speed be, at least compared to if they were running? Which of these would be steeper? Okay. And then we're going to continue through here. Once again, your sub should have the answer key, and you'll be going over that probably towards the end of class. All right, coming back here. Okay. Alright, so now how would we calculate the speed for each segment of a trip? So think back to yesterday. What was our formula for speed? Okay, it's our distance over our time. So let's take a look. We need two numbers, our distance and our time. So looking at point B, my distance is 3 meters and my time is 5. So grabbing my calculator here, I'm going to do 3 divided by 5. And my calculator doesn't want to work. Sorry about that. Come on. 3 divided by 5 is 0.6. So here my speed would be 0.6 meters per second. Alright, now what about from B to C? Well, I'm at 3 meters, I'm at 3 meters. So I don't say 3 meters over 8 seconds. I've traveled how far? Nowhere. I started at 3 and I ended at 3. I haven't gone anywhere. So let's see, 0 divided by whatever is, guess what? It's 0. My speed is 0. Alright, now from C to D, this one's a little bit more tricky because I'm going from 3 up to 12. So you'd think, okay, well 12 divided by 12, my speed must be 1. But no, because I'm only doing with this one section of the line. I'm not doing all the way from the beginning. I'm only doing from C to D. So what I have to do is I have to take 12 and subtract 3. Okay, so that's going to give us 9, right? And then we're going to divide that. So 12 seconds minus 8 seconds, okay, that's 4. So we would do 9 divided by 4. And so our speed here would be 2.25. And then our speed for our last section, from D to E, well, guess what? It's still 0 because I'm not going anywhere. Alright, so we got 0.6, 0, 2.25, and 0. Alright, and now for our last assignment that you guys are going to be working on. Okay, so we've got two data tables. We are going to graph on this graph down here what both of these lines would look like. And then once you do that, there are some questions down here at the bottom. And once again, your sub should have an answer key, and you guys will be going over that at the end. Alright guys, I hope you have found this informative, and I look forward to returning. Alright, bye.